Hi, I'm Carol Willis. I'm the founder, director, and curator of the Skyscraper Museum. And this is the last of the programs that we have run in coordination with the exhibition at the museum, Tall Timber, The Future of Cities and Wood. And you all found on your chairs this invitation for tomorrow night for the closing reception because we're in the last 3 days of the show. So if you haven't seen it yet, I hope you will come down. The museum is open on Wednesday through Saturday from noon to 6, and admission is free. So you should definitely stop by, and you can even come after 6 o'clock tomorrow. So I hope that you'll be able to do that. You can see what the show looks like a little bit at its entrance, and if you haven't been to the museum, our fairly small space into which we do pack a lot of content. And we were really pleased to be able to take this exhibition, which was originated at the Chicago Architecture Center with the Council on Tall Buildings and Urban Habitat, by a lot of people who are very serious about mass timber. For the museum, the Skyscraper Museum, we changed the show around a lot. We took very seriously the climate consciousness carbon cost benefits of mass timber. But we especially explored the history. In fact, like on the screen, the short history and promising future, we hope, and that's what we're going to talk about tonight, of mass timber buildings. And for that series, we started with people who have been in the field for a long time, and the idea where with mass timber, you always have to begin, which is managing the forest, responsibly managing the forest. Lindsay Wickstrom spoke, two engineers. Michelle Roloffs and Tanya Luthi did a Mass Timber 101 webinar. These were webinars, but there were also in-person programs and shop, this time with Chris Sharples instead of Bill Sharples like tonight, and Thomas Robinson from Lever Architecture talked about these two important projects from 2014. And it was a historical approach that we took to mass timber. We wanted to look at its short history, which is only about 10, 12, maybe 14 years in North America, though longer in other places. Other people in the series, and I'm telling you about these because you haven't missed them. You can still watch them on video on our YouTube channel or on the museum's YouTube channel or on the museum's website. And so each one of those lectures is an hour long, so you can consume like 10 or 12 hours worth of mass timber detail. One of the early advocates and evangelists was Michael Green. Other people who spoke are Susan Jones from the Pacific Northwest contingent of mass timber. We had a program where we emphasized in particular embodied energy with Alan Organsky and David Lewis, and Fred Bernstein, who's here tonight, but was beamed in from his COVID bed that particular night. Worth watching to see Fred's giant head on the screen. Andrew Waugh from the UK, who even before many of the mass timber advocates in the US began to explore and build the first high-rise mass timber buildings. And then SOM and Thornton Tomasetti and other engineers participated in an evening called Height and Hybrids that looked at truly taller buildings, 20 stories and above, and combining materials for their greatest virtues. So in all of those lectures, which I wanted to mention again here so that for those of you who missed the show and missed the lectures and were attracted here by the subject tonight and by Justin Davidson, I hope you will consume those and look as seriously as we tried to do at the museum at how mass timber can really change the future, especially if it's adopted in mass consumption and production and consumption in cities in high-rise buildings. And that's why we wanted to do it at the Skyscraper Museum. But Justin Davidson is going to talk about his agenda and his vision for the commissions and the 4 architectural teams that were put together by him for Curb Magazine and New York Magazine. And some of you have now had the link of the article which dropped today. So a beautifully written article and terrific work, very innovative, which you're going to hear about now.
Thank you, Carol. Thank you, Carol, for organizing this event and SOM for hosting it. It's great to make the transition from our solo behind the scenes work of writing and editing and putting stuff online in a magazine to actually being in front of people. And thank you all for coming out on a bitter night to talk about warm wood. One of the privileges of my job as critic, as architecture critic at New York Magazine and Curbed, which, by the way, are basically the same thing. Curbed is a subset of New York Magazine, is that aside from my usual responsibilities of reacting to what's out there, to ideas that other people have, occasionally, a couple times a year, I can go to architects and ask them to respond creatively to some issue that we're talking about. And so, for instance, I was interested in what the possibilities were with new funding schemes to renovate and expand NYCHA buildings. What that kind of financial change opened up architecturally, and PRO, Peterson Rich Office, responded to that. There was a church on the Upper West Side where basically the choice was between letting it fall down by itself or having it demolished quickly. Either way, didn't seem like a great outcome. So I was interested in what we could do, or what an architect could do and for adaptive reuse to make it make sense to keep, but transform something that would please landmarks. And DXA did that. But we've done a number of these kinds of speculative projects. And in this case, I wanted to get at timber from a point of view that would appeal to readers who are not already enmeshed, who really don't know what mass timber is and who are not, don't have a pre-existing interest. So I wanted to move not beyond, but step sideways from the sustainability virtues of timber, which, the whole lecture series that Carol curated went into in depth, and many other articles have. Not to ignore it, to use that as a springboard, but also to talk about what kinds of architectural and expressive possibilities this technology and this use of material opens up. Because I saw that New York, as is its wont, moves cautiously in adopting new ideas. And when we're talking about wood in a dense city, the fire department has the last word. And so, things are moving slowly, more slowly than they might in other parts of the world. And so I asked 4 different architecture firms of different sizes and different profiles if they would be interested in trying to imagine what New York could do with timber, or with mass timber, what a timber city could look like if it really embraced the material beyond what the code allows. So they were all enthusiastic in responding. And I went to firms that have experience with mass timber, but aren't specialists, because I wanted to not try to sell it as a virtuous material, but try to understand for myself and for readers what we haven't thought of. How could we envision buildings that don't do what they do, not only do what they do better, but also look immediately like things that were conceived in timber to begin with, and that could really only be expressed that way. And I wanted something very clear that readers would respond to instantaneously. So I knew that meant a lot of research and writing on my part, but I wanted ultimately renderings that a reader could open and say, oh, wow, I've never seen anything like this. Oh, that's really cool. Very simple, immediate responses. That involves a lot of crossing of fingers. My first job was to sell this internally to my editors at Curbed, who were like, maybe? I think this could work. And of course, like, as convincing as I was ultimately, I was also kind of like, I hope this works, because you just don't know what you're going to get. I'm delighted with what we got. I think the efforts, architects are amazing. You ask one person, oh, would you be interested in doing this? And before you know it, I've got 8 people flying in from Arkansas, having spent weeks developing a design. And not only that, usually we only do this with one firm, but we've had four, including Modus, ZGF, Shop, and SOM. So that's an amazing range. And as you'll see, the projects are quite varied. And I want to make it clear, I made it clear in the article to the reader, it should be obvious to this crowd. These are not real projects in the sense that we're by design, by definition, doing things that are illegal, because none of them really conform to the code. They're aspirational. They are intended to guide readers to create a desire for something that we can't have right now. Because creating a desire is kind of what city development is all about. Until readers, New Yorkers, feel this pull towards what we could have being better than what we actually do, things don't happen. So I thought that was an important thing to do. So again, these projects can't legally be built in New York, but I wanted to make sure that they were realistic, that they could be built, that we could have them, that ultimately the obstacles that we face in terms of the adoption and the sort of liberation of mass timber as a new kind of creative force are less technological and even financial than they are procedural. Let's just face the fact that we are not building these things because we don't want to. And that's really kind of the limiting factor. So in creating desire in readers and consumers and the general public, I'm hopeful that we can kind of put some pressure on facing that eternal New York truth that things don't happen just because they don't happen, and to try to move the needle in that way. So having said that, I'm going to turn the microphone over to the first of our presenters, which is Kate Mann from ZGF.
Thank you. We're super excited to be here for a couple of reasons. One, being ZGF, we're never first. We're always last, alphabetically. So that's a big win. But we're also really excited to talk about mass timber today. So we really took this notion of bringing mass timber to New York to really think about what that might mean. Of course, it means a more sustainable city, may even mean a more beautiful city, but could it mean a healthier city? Could it mean healthier New Yorkers? So we at ZGF have recently completed a white paper that's all about mass timber hospital. And it was some of our experts across the firm, both in healthcare and timber, doing a deep dive into what that meant. And one thing that was a really interesting takeaway for us and became a catalyst for this project was that being in an environment that mimics the natural world actually promotes healing. It's a healthier environment, and it's demonstrated in patient outcomes. So as we thought about this, we really started thinking about how to bring that to New York City and where to do that. So we came up with this idea for our Harlem Community Healthcare Center. Of course, we as architects are always thinking about how we can help as designers and as architects help communities thrive. And we know, of course, there's different healthcare disparities across the city, different marginalized populations historically that may have distrust of institutionalized healthcare. And it seemed to us as a great opportunity to make an intervention in mass timber that would both be beautiful, sustainable, but also help a community find wellness. Because we do believe that mass timber applied to healthcare can lead to that stronger community, to greater health, and have faster impact than conventional construction. So first, a little bit about ZGF. We're from the Pacific Northwest, which you may know, but that gives us very deep, intimate knowledge of timber, both in the sort of sourcing in the forest, but also in the form of mass timber construction, which we've been doing since the 1970s. We've done it across a range of project types, a lot of offices, also airport, athletics, even our community library. And we'd love to bring that knowledge to bear on healthcare. You may have seen this, which just opened in August. This is the new Portland Airport expansion. So we're continuing to innovate in timber. And this project was interesting because it really brings not just timber, but daylight and biophilia together to really complete a totally different airport. So really transform the airport experience. And it does a couple things. Originally, the intent was to design an airport that inspired the feeling of a walk in the forest, and as a way to welcome visitors, of course, to the Pacific Northwest, where that's very representative. But what it's done, and if you visit, it has done that. But the other thing it's done is really evoke a sense of curiosity, fun, playfulness. It's taken away the stress from the airport experience. And, those are not words that I normally associate with an airport. But if you go to this airport, you see, there's kids playing, there's people singing. It's just a very different kind of experience. This was interesting. So we're New York's best kept secret. I'm always meeting people who don't know that ZGF is here, but we've been here about 25 years. So we're excited to bring this expertise to bear in New York. So what would this mean for New York City? Just starting with the stronger community, we really wanted to evoke that sense of shelter in place that a tree provides. And the reason to do that here in Harlem was really to create a welcoming presence, a warm and welcoming presence for healthcare in a community that has historically a distrust of those institutionalized healthcare organizations. So what we did is design this very sculptural tree-shaped column that holds up the canopy of the building. It could be read as the dappled sunlight of the forest. And that really creates this public plaza at street level. So we're able to give back to the city and create a place that people pass through every day, or they can stop and play in. And it's not just about healthcare. We use biophilia. So we have rooftop urban farm, rooftop gardens, but also played with sort of color, materiality, texture, and pattern to really evoke that sensibility. This is a terracotta research we had done with ACAW up at in Buffalo, but we found that the glazing, that rich green glazing, is very evocative. So that became the cladding and sort of represents the branches of the building. And then we exposed the timber and used that pattern to really create this inviting, welcoming presence. We have two different timber systems we're using here. So we have the macro columns, which hold up the building, particularly in the public spaces, both interior and exterior. And then the body of the building is a beam and cassette system, which we'll tell you a little bit more about. But what those big tree-like columns let us do is push back that ground floor curtain wall and really create that public presence. And we thought it would be really great to use that, not just to support sort of daily activities, but also it could be a farmer's market. And that farmer's market could work with this rooftop urban farm and the demo kitchen and really create a resource for the community around wellness, around healthy eating. It's more of something you use every day, so that that community is more likely to come here both for screening and treatment. We believe mass timber leads to greater health. In fact, this is the white paper I was telling you about. This is a very, very deep dive. It's available online. You can get to it through this QR code, but it takes up, sort of addresses point by point a lot of the hesitations around timber and healthcare and provides solutions. So it talks about column-based spacing. How do you clean it? These kinds of issues. But ultimately, what comes away from that study is the benefits of mass timber, some of which Justin touched on. We know there's a low carbon footprint. We know there's sourcing benefits, a very diverse supply chain reaching into rural communities. There's cost efficiencies. But I think the one that we kept coming back to is this idea of that, and it seems obvious, but healthy environments lead to healthier outcomes. And I think as humans, we can all appreciate that. So that white paper really became the driver for the design of the space. So this is a view in the upper part of the building and some of the treatment spaces. So you can see that tree-shaped column again, which is translated into a double height living room. It has biophilia and daylight, views to a roof garden. And it's really there to support families as they're with loved ones through their healthcare journey. And it's meant to deinstitutionalize healthcare. It's meant to have a more residential feel and less institutional. And that happens as well in the treatment rooms, where you see the exposed timber, the posts, the beam, even the cassette and the ceiling. There's no drop ceilings, which you normally might associate with healthcare. The only drop ceiling we have here is in that corridor. And then timber, of course, faster impact. It's essentially prefab. So whether that's the long span glulam at Portland Airport or your typical office building like PAE, we've been very curious in exploring this beam and cassette framing, which I was grateful to see SOM with their CLT stair there, because this system is made of 2 layers of that with ribs. So very heavy floor, but what that lets you do is span from beam to beam with one prefab plank. And that minimizes the height, the floor-to-floor height, reduces the amount of cost or curtain wall, and simplifies mechanical coordination. So there's a lot of simplicity in that system. And we know that leads to faster project delivery and less impact on neighborhoods. So we're very excited about wood here in New York City.
Thank you. One of the things I found talking to the architects as they were going through developing these projects is how quickly they all started talking about the experiential nature of the architecture. And partly it's the way they think, but partly I think it's the way wood, mass timber leads people to think. And that's really something I was hoping to get out of it, was the sense that not just what these buildings look like from a distance or in a picture, but what it would feel like to be in them. So the other highest stress environment besides any place you go to be cured, hopefully, is an airport, as we know, and ZGF just designed the one in Portland. SHOP took on the task of trying to make LaGuardia into a place you actually want to be, not just go through. So we're excited to see that. So this William Sharple's one of the founding principles of SHOP.
Thanks. So I just want to introduce collaborator Steve Garcia, who's associate principal at SHOP, who worked with me and Chris to deliver this idea we had for airport in mass timber. But what I wanted to do is kind of, when it comes to new technologies, and wood is not a new technology, but going through code and trying to understand, how do you engineer, how do you put it together, how do you sell it to clients? It's not linear. And you have to go through experience. One, it starts with a client who is looking for willingness, resiliency, this natural material, access to biophilia and daylight. And we've been lucky, similar to everyone in this room, to have clients that are really progressive, looking for that. But for us, our first project, we're talking about 1998, Mitchell Park was a competition, first project, Carousel House. 7 years of higher education, you tell your parents your first project's Carousel House, you get a kind of strange reaction. But for us, this was our first project, and it was mass timber. And what was interesting about it is you kind of learn in the process. And for us, at this period of time, we're talking about late 90s, we did not have, grasshopper, rhino grasshopper, or CATIA. We had to kind of figure it out on the fly. And for us, it was really creating the models, working with the carpenters, master carpenters, understanding how these geometries would come together, but ultimately how a hybrid structure would formulate to create this large span structure, which is, working with the compression ring, tension ring, flitch vents and columns to create something that came together, understanding, how the different materials react to temperature, moisture, but at the end of the day, come together and they last. This building is going on its 23rd year, has never been touched. And that really comes down to, again, the material and the craft, and also just understanding the behavior, which Steve will talk about. Jumping to more the present, we're working on a project for YouTube expansion of their campus. This is a phase 1 of a 5-phase project, about 400,000 square feet. Again, hybrid, steel, wood construction. Susan Wachowski, who obviously we lost this past year, was the visionary. She wanted a campus environment. She wanted buildings that really were embraced by the neighborhood. this idea of biophilia, access to natural daylight, most importantly, the idea of wood being part of that story. And again, the challenges obviously with office buildings, we're looking at long span structures. So again, similar to some of the things that ZGF has talked about, is how do you bring these hybrid systems together, but do it in a way that is elegant, and at the end of the day, it is the finished product. And one of her visions was this idea of campus and how the materials and biophilia would bring people together and create this kind of place where people would want to be and collaborate. Which is interesting because in the project that's following, which is also under construction, the Atlassian Tower, is the vertical campus concept. This is a 44-story hybrid structure. Basically, it's made up of what we call 8 habitats that are tied together with the concrete core and exterior steel exoskeleton that hold these kind of large-scale tabletops, then which 3 levels of CLT structures are then planted on top with a fully ventilated exterior facade. And again, the idea here, the vision of the founders of Atlassian is they wanted this access to natural, to the air, to natural biophilia, but also this idea of access to natural materials. So each neighborhood has its own kind of experience, its own parklet. And again, the idea of distributing community, but in campus that is in a vertical context. And this project is under construction, and we're hoping, topping out towards the end of this year. Which brings us kind of to the more tactile aspect of mass timber and wood, and how do we begin to think about how human beings come in contact and direct, and then in some sort of bringing it down to the scale of the human being. And again, 2000, our first commission that we got from PS1 MoMA, Dunescape. Here we're working with 2x2 cedar segments that we conveyed this idea of what we said, programs of the beach, the idea of the program, the structure, the form, all acting, utilizing one material. And again, the flexibility that the material had, but also in terms of how people inhabited it and kind of engaged it, reinforced the power in terms of what wood and architecture could be in the public realm, which then translated to a project that we did about a year later, the Hangill Bookhouse. Again, now taking the tools that we used to develop, pretty rudimentary PS1 and really refine them into a project that really was about craft. Which brings us to the last project before that we lead into the airport proposal. And here, this is the National Veterans Resource Center. It was finished in 2021. This is a project up at Syracuse University. And the focus here was really to create this iconic element that would, greet you, but and again, really express the idea of, natural material and expression. And, one of the challenges, and what we call it the wood wave, it houses this about a 950 seat auditorium inside. But the focus here was understanding how we could take materials such as cross-laminated timber and articulate it into a geometry that really expressed, the beauty and something that people could actually come in contact and look at in terms of structure. And again, it comes back to the tools we are now able to use, our firms are able to use today. If you did not have these tools, 15 years ago, it's a different outcome. And here it's a grasshopper rhino script that's developed in-house that then we work directly with the fabricator, and then we give the models to the fabricator, and they continue on all the way into the process of the execution, where you're taking the systems of the infrastructure, the mechanical systems and the lightings, and you incorporate them into a kit of parts. And this is where, design, DFMA comes into part. This idea of prefabricated modular construction really lends itself in terms of how this material can be really pushed to this incredible expression and experience that you've seen in a number of the projects that ZGF, SLM, and MOS have produced. And this is kind of leads into kind of what Steve's going to present. quickly in terms of how we bring this kind of complexity, but understanding how that complexity takes on how the wood's behavior, the natural behavior of the wood can be actually, utilized in a way that really expresses something that is what we call somewhat delightful anyway.
Thanks, Bill. So, anytime we work with wood, I think we're immediately inspired by the unique beauty. I think to borrow from Justin's article today, I think the discussion was around organic, industrial, artisanal, right? These ideas. And so, if we think about that idea of what the organic material really is there an opportunity to then look at this and say, can we actually embrace potentially what might normally be considered a defect within that process? So early in our research, we came across some proposals and work of the University of Stuttgart, looking at ways to actually embrace kind of these types of, understandings of the innate qualities of the material itself. In this case, looking at the moisture content within the wood and how the drying process itself potentially has an opportunity to start to create and inform the process of the design and the form itself as it goes. Of course, looking at things like the Eames leg splints as well, here where, equal parts expressive, utilitarian, right, in its purpose. The forming of the material, the wood again, really in this case, the form is about creating the stabilization, right, and like building out that rigidity that helps provide sort of a proto-structural approach that is equal parts, finish at the same time, which was something that really drove us in the way that we wanted to think about how we express the uniqueness of the wood in this particular material or this particular proposal, where utilizing modern technique, CLT, of course, and thinking about how the layering of the structuring of the wood could actually be at the same time, the structural proposal, looking at kind of an integrated skin approach, but also the finish. And thinking about then too, with that, can each of those systems, like can it be finish, can it be system, can it be structure, all in one integrated proposal? Looking at the proposal here for kind of a composite integrated stress skin, also steel flitch columns, kind of harkening back to what Bill was talking about earlier with this idea of kind of the hybrid structures and sort of a through line to a lot of our current study in the office. And, then of course, applying that to the idea of the terminal, which of course with ZGF, talking about the idea of, the inherent stresses of the travel experience. Can we utilize that sort of humane quality of wood to really alleviate that stress and create a new experience? And in doing so, also at the same time, marry that with digital technology, marry that with prefabrication and other methodologies that allow us to really utilize the fullest extent of that potential to alleviate some of the considerations of an operational airport needing to be, continuing operationally as it goes. So really in the vision of the airport overall, the idea is to, create a space that is equal parts structural, equal parts finish, equal parts systems. It brings together this sort of warmth and humane quality to a very inhumane experience for many of us that we envision in many parts of our lives and many days of our lives. And so we're excited about kind of where the proposal ended, and certainly we would love to see kind of pushing this forward into the next round. Justin?
Thank you. I want to go there. One of the other things that kept coming up as in the process of working with all four of these firms was not just what the experience is for users inside the building or going through it, but how it relates to the city around it. And, that's a tricky thing because we're talking about a new material or a new expression of material, often in dense contexts. But what we found was that it's already set up for that. There's already kind of a very fluid, intuitive connection between these designs and the city around them. And you can see that in the next one. I wanted to make sure, and in a certain sense, even though we were being New York focused, to de-New Yorkify the project a little bit. That is to bring in voices from people who are less steeped in the restrictions of New York, because I think, the more familiar you are with how things are done here, the more effort you have to make to kind of imagine what you could do. But if you're coming from outside, it's like, well, sure. And so I found Modus from Arkansas, who had worked with Grafton on one of their numerous buildings there. And they were working on a school in Red Hook. One of the other things I wanted to make sure and do was diversify project geographically throughout the city. So this is a school in Red Hook, and Chris Barrow will present, and he'll show you how that school relates both to its program and to the immediate neighborhood. Chris?
All right, hello. Such a perfect image, having flown in at, or got up at 4 a.m. this morning and flew from Arkansas, and the stress that comes with that. That is definitely a space we'd love to depart and arrive to. All right, I'm Chris Barrow with Modus Studio. And we were really excited when Justin reached out about this potential for this article and for this conceptual idea about bringing what we think is a potential practical resolution into what construction should be for K through 12 schools. And so we started kind of with this inspirational image, this kind of idea of canopy. And in a state that is 57% forest, like Arkansas is, canopy is a very powerful word to us. We live in the forest in Northwest Arkansas and Fayetteville, where we are from. And of course, much of the state is a forest as well. And so this idea of being in the trees and how important that is, all of the biophilia ideas that are talked about are sort of ingrained in our Arkansas roots in a lot of ways. So just a few brief projects that sort of got us on this path to where we are. First off, this is the Adohi Hall at the University of Arkansas. And this project was a three-way partnership between us and Lears Weinsappel and Associates and Mackey Mitchell Architects. And when this project was commissioned, it had sort of this mission of becoming an icon for mass timber in the state of Arkansas, a big push by the university. And in fact, one of the members of the audience here, Dean Peter McKeith, who helped kind of generate or push for this, why can't we use the material, the resource, the local natural ability that we have in the architecture. And so this is about a 200,000 square foot facility. And at the time of construction, certainly the largest that was in construction, I think in the US, and the first university building. And so the idea that occupying the land, having a strong landscape presence, but also bringing that landscape into the building as part of the architecture. And that I think is one of the, the great powers of mass timber. And I just want to say a kind of a staggering sort of statistic for us in our state is that all of the wood that was used in this building can be regrown in the state of Arkansas in our forest within a matter of hours. So I don't remember the exact figure for the amount of volume of timber that is in this project, but it's sort of staggering when you think about that as a material, as a resource for us in architecture. And our partners in crime and construction on Adohi Hall, who we learned many, many valuable lessons with, immediately kind of turned to us or looked to us to develop their own office building. So this is the Nabholz office in Rogers, Arkansas, a very simple, straightforward, but yet simple and elegant project utilizing a mass timber system, simple, glue-lam and CLT, and of course, even the opportunity to create furniture out of elements, something that we sort of learned along the way in the Adohi Hall process. But again, very stripped down, very simple. This easily could have been a pre-engineered metal building, but they really wanted to embrace the idea that that the experience of wood is great for people, even on a daily basis in their workplace. And at the same time, we were also working on this office building in Bentonville, Arkansas, which obviously, if you pay attention to mass timber, largest retail company in the world, Walmart, is completing their huge campus, mostly crafted out of mass timber. But we did this first, and we did this for sort of a family member. There's a developer within the Walton family. And so I at least would like to think that we sort of tipped the hat this direction. Working, there was actually a renovation project, but we had to sort of scoop out the middle of the building and do a 2-story volume of mass timber. So we worked with Structure-Lam on this and Nabholz to construct it. And again, an office building, but not a single purpose. It had multiple places, so we could get a lot of companies in the small spaces within the timber to really extend that performance of the material into the community. So again, simple construction, I think an elegant solution for a work environment. And then this ultimately led to, as Justin alluded to, the University of Arkansas School, A. Jones School of Architecture, under the guidance of Dean Peter McKeith, who's a friend and mentor and client of ours, he put on a competition. Ultimately, Grafton Architects was awarded for this concept, and we partnered with them to realize this building, which is currently under construction and is really going to be fabulous, and an incredible facility, all crafted in wood, and really obviously portraying all the qualities of the wood in an almost cathedral-like space, yet vernacular in its barn forms, I would say. And so these are some of the fabrication labs that ultimately will result from that project. And then recently on site, partners Jason is here with us, and then Yvonne Farrell from Grafton Architects, as they're sort of here during the topping out ceremony earlier this year. So we're excited about the resolution of this project very soon. And then currently we are working on a new junior high in Fayetteville, Arkansas. We've been doing K through 12 work all over the state of Arkansas, and finally we're able to land one in our home city. And luckily enough, this is called Woodland Junior High, and that's the name of the existing junior high that is then being transported to a new location. And so honestly, selling this concept of mass timber to the school for not only all the sustainability reasons and all the biophilia reasons, but it's called Woodland. So why not embrace it? So we're really excited. We're in the construction document phase on this. But as you can see, celebrating the timber throughout, whether it's part of the arcade, it's part of the front porch to the entire project. And then inside, even celebrating the CLT as part of the glue lamp as it all comes together for student-focused student health and well-being. And even corridors, the school's actually very excited about this potential that could be a school corridor instead of concrete block that gets repainted or drywall that gets damaged. And again, as part of the biophilic conversation, there's a lot of research that really speaks to, sorry, something got it shifted there, but it speaks to the positive outlooks of the biophilic design, how test scores can be increased, how stress reduction can be increased, stress response can be reduced, I should say, in a more biophilic design, and lower blood pressure ultimately. There's a lot of research about this, but my gosh, what could be a better place for like really implementing that than where students spend 8 hours of every day for 9 months of every year for 13 years of their life. Like this is the kind of thing that we need to really push for. So moving to the project, when Justin reached out to us, we wanted to find a school. And so we found a site through a research process in Red Hook that had been selected and slated. I believe a design had been done for the site. So we really wanted to begin our research and begin our understanding of the place. We are the outsiders. We are from Arkansas. We do not know this direct context. We do not live in it. But I think that sort of caused us to sort of turn over the rock, pull back the curtain, look a little deeper, and try to understand the place. And we really loved that this site was adjacent to Coffee Park. So as we began sketching on the project and just thinking through, obviously we could go any direction we wanted to in a conceptual project and under this commission, and the direction the article is going, but we're always sort of tied to sort of pragmatism and a real desire to see this happen in K through 12 work. And these structures can be really beautiful, even when they're simple, even when they're plain. And that's not exactly where we landed, but just the idea of post-beam and CLT exposed and what that could mean for kind of introducing this idea of canopy into a project. And then further sort of studying how to sort of bring the idea of Coffee Park into the building, to really extend the idea of the park for it being a place where students can be educated, for 8 hours a day. So basic diagram of the concept, you got Coffee Park in our site, extending that forest or that canopy or that greenery onto the site, conceptually growing that to become the project, and then ultimately, how do we inhabit layers of canopy throughout. So as it sets within the context, again, with Coffee Park there in the lower left, and we also embraced sort of this existing warehouse that was on the site. And part of the program for the school was to have a natatorium. So we just sort of kind of ran with that existing program. but also wanted to kind of embrace a little bit of the context that is there. Obviously, a strong masonry construction and more density perhaps than we often work with. So elevating these ideas into the overall design. So we have along Verona Street, and of course across the street from Coffee Park. That's the concept. Again, we utilized an existing building within the overall fabric. And as you zoom in, one of the striking things for us is a part of the way to extend the park, elevate that, and really create a community space is to create the community front porch, which is sort of a beautiful arcade crafted in pieces of the forest, perhaps. So we have a series of glulam columns that define the courtyard, the secure courtyard that's beyond. Obviously become the entry and lobby, and see how it sits up on site with the natatorium being tucked back behind the existing facade. So on the right is the existing building that we wanted to save the facade, and we really took cues from that diagrammatically and experientially for sort of the rhythm of the brick columns and the balusters became the rhythm for the arcade for the community porch as we set up the column grid. And then as we created that sort of zone, that community zone, as you can see, it moves from the street to the sidewalk into the courtyard to really create a community space that would be meaningful for the public. And then above that, just a series of classrooms, with exposed CLT ceilings. And so as you're walking on the street, you're going to look up, you're going to see the wood at night, it's going to glow and do all those things. On the inside, just again, the potential for a very simple, rigid structure of glulam with post beam and then CLT floors and roof structure. And, just what the idea of that social space could be. So this is the main lobby with the secure courtyard off to the left, and of course the streetscape out to the front. Again, we love just the impact that we're studying right now in our home state, the potential impact this could have here for really creating lovely, lively spaces for students to engage. And then again at night, and you can even see how we wanted to embrace this as sort of a lantern. We kind of made a mixture of the masonry, the contextual material from the site and from the rest of the buildings, and merged that into the mass timber so that this could be, theoretically constructed in a very straightforward way, but yet craft something really beautiful that's meaningful back to the community and to the public as it's occupied.
Along the way in putting together this project, I was also, thinking about the ways that new structural systems at the end of the 19th and the beginning of the 20th centuries, namely steel and reinforced concrete, really transformed the way architects thought about structure expressively. And how many things and the variety of architecture that flowed from that. And I was hoping that we collectively could capture some of that excitement in this project. And so along with the experiential, the urbanistic, the wellness, and of course the backdrop of the sustainability aspects of timber, I was also just really hoping there would be a project that would clarify the potential of this material where structure and finish are the same. And also as Bill Sharples and others talked about, where the craftsmanship would really kind of be self-evident. I think it was Bill or Chris who said, as we were talking about it, we're bringing the arts and crafts movement into the 21st century. And that idea of a building where you can actually see the detail, and where there really, because of the offsite milling process, there really are very few limits to the level of detail you can engage in. Right? It doesn't have to be done on site. We don't need Sicilian craftsmen, chipping away at brownstone. We can do this in a contemporary modern way and really lavish attention and appreciation on the connections between the tiniest detail and the largest structure. So just having set that up, I'll let Colin and Pritam talk about their project, which is our largest, grandest scale project. But which is also sort of visibly eloquent at the detail level too.
A quick change out from generic mass timber stadium title to the Queen's Braid, which is what we decided to call this. I'm here with Pritam, who will present this together. And, I think like many of the other architects said, like there's been a long investigation here at SOM about mass timber. One thing that I think defines SOM is that investigation has been a marriage of the architectural discipline and the structural engineering discipline. So whether it was a typological investigation of mass timber at the scale of a tall tower, which was done about 20 years ago, to the actual testing of systems, which we do regularly in mechanical laboratories to establish the most efficient and optimal design of these, to the exploration of those materials in small pavilions and other elements, up to and including actually the design and patent of the actual steel connections for timber systems, which SOM is doing right now. So hopefully you'll all spec those so we can get a nice little cut of that. But also looking at the way that a structural engineer thinks creatively and the way that an architect thinks creatively are harmonious and distinct. And I think much of our investigation of architecture emerges from the marriage of those two distinct points of view, which is the search for efficiency, the search for beauty. Both architects and engineers do both of those things at SOM. This is obviously, I think, one of the more prominent expressions of public timber architecture in New York. This is the High Line extension that connected Manhattan West to the High Line itself. And now you have the ability to get off of a train at Moynihan Train Hall and by only crossing one street, then access the High Line and walk from Moynihan Train Hall all the way down to the Whitney. And it is a heavily used project, and it was done in a prefabricated trussed structure, which was actually installed over a weekend, which is one of the real advantages of timber. This is something that we're working on right now in the office, which is on Governor's Island, the Climate Exchange, Living Building Challenge, full certification, but it is moving away from just that pure prefabrication and more into a variety of issues that are being examined, not just the use of low carbon and decarbonization in general, but you're also seeing a net zero building, which is about energy performance. You're also seeing a resilient landscape, which is elevating the entire project and protecting portions of the island from sea level rise. And so I think when we talk about mass timber, we have to place it in the full spectrum of what we have to do as architects to be able to confront the climate crisis and the equity crisis and all the other pieces that I think designers are at the front lines of. I think Justin just talked about something that I was hoping he would, which was, when we first started talking to him, he asked us, he had a kind of thesis, which was that, modernism really grew out of large technological advances that designers and engineers had to grapple with. So the advancement in the ability to construct high-grade steel structures, the advancement in marrying those to concrete and looking at concrete structures. And it took several decades to go from the initial prototypes and rudimentary structures and often industrial buildings, and we think of Albert Kahn and his beautiful buildings, to a place where you had Nervi and Candela making gorgeous vaulted concrete structures, and you had Faz Khan at SOM exploring what the limits of steel were. And those experiments really emerged from the innate qualities of those systems. And today, I think all of us as architects are familiar with, you want to push mass timber, and so your cost consultant is giving your client information on whether the building is concrete or timber or steel, and then you're looking at the variety of those. There is an interchangeability to these systems. They are interoperable, but it was interesting for us to try to think, what if we started with the innate quality of timber, and what if we tried to do that at the largest scale possible? We are SOM after all. We like big things. And I love sports. I would just like to say that. I'm going to own that. A lot of architects are like, what? But these cathedrals of spectacle are the places where people most experience architecture. In many ways, like some of their deepest memories are these places. And they are buildings which New York used to have gracious, incredible stadia. And now I think we have, I will just say, perfectly good stadiums. And I say that as a Minnesotan who's transplanted here. I think probably the most prominent of those is Yankee Stadium, which is actually embedded in a neighborhood and a community, but many of the stadiums are at the perimeter of the city and are quite hard to get to and aren't great experiences, frankly, when you get there. And it seemed like a chance to do what Ebbets Field did, do what some of the other places did, and actually bring the stadia back into the city. Citi Field is doing that. They're trying to build a community around that. But it's not quite at the convenience level of like Shops Barclays Center, which is like right there, or MSG. And I think one of the reasons that basketball and it has a kind of special place in New Yorkers' heart is because you can get there quickly. So we wanted to find a site that was somewhere accessible, somewhere closer to the heart of the city, but still wanted to be in a borough. We're kind of using as a springboard the program of the new NYCFC stadium, which is about a 25,000 seat soccer stadium. My son's probably on this YouTube and screaming that I should call it a football stadium. I'm going to call it a football stadium from here on out. But the site we actually honed in on quickly was part of those sets of issues I talked about at Governor's Island. Climate change, the growth of the city. And when you look at New York over the last 25 years, one of the biggest things that happened is in an attempt to sort of knit the city together, find places for density, but also be able to sort of raise the elevation and protect the city. There's a tremendous amount of development at the city's edge, particularly in the East River. And the site that's sort of next in line is just north of Long Island City. It is this site that is predominantly, not entirely, but predominantly owned by Con Edison. It's largely unused, but yet if you walk a few blocks east, you have all of those subway interchanges that you get at Long Island City. And you also have this. I mean, how can you not want to place a stadium that close to the city and kind of build off of that idea? So we had a site, we had a program, and then comes the question of what is the form? And I will now hand it over to Pritam because the one thing I'll leave you with as Pritam starts is it's not the plasticity of concrete that makes wood special. It is not its ability to deal with tension that makes steel special. It is fiber strength. That is what timber is.
Thanks, Carl. So we thought the best use of mass timber, if you want to do that, we need to examine the properties and the qualities of timber itself. So we wanted to look at inspirations in nature, a bird's nest. Really, a twig is a mass timber for a bird. And also in craft, the art of weaving baskets and the efficiency of these two systems. Because everywhere, when you see these two, you only use the material you need to. A bird doesn't want to use more material than it needs to for a nest. And neither do these baskets. You all know that you need to carry it. You use more materials, it becomes heavier, and that defeats the purpose of the basket. So we thought, let's look at efficiency and how do we use that in building. So of course, we know as a structural engineer that the best form and the most efficient form is a shell. But here's the conundrum. A shell wants to be a continuous surface. And how do you make that with discrete timber elements? And that was the question we asked ourselves. And it needs to be two directional. So we thought about it. Unlike concrete or steel, where elements are all on the same plane, if you put timber in two directions in the same plane, only one direction becomes continuous. That's the first image. Well, you can make it continuous in two directions by actually layering it, but then either one of the directions starts becoming primary, the other becomes secondary, or you have to layer it multiple times. And this is where we started looking at the art of weaving. Can we actually weave in a way that it alternates itself up and down? And what it does is it creates a two-direction continuous members, but it also creates something that doesn't have a primary side or a secondary side. It is continuous in both directions. So before we get into the actual element efficiency, we wanted to also look at the efficiency of the form itself. So we did two things. We looked at the planar efficiency, and we looked at the efficiency of the top ring and shaped it into a print. What it does is it creates two things. An improved efficiency. So you can see that as we did the study, the deflection is half in the graph. And what you also see in the diagrams below, by doing this exploration in plan and in form, you've eliminated all the hotspots, which means now this form is using the best use of the material itself, maximum use of every cross-section of timber. And by doing these two, what we get is a woven timber shell that is made of two directional timber elements connected together with rings that are in steel rods, just like hoops in a timber barrel. And that is the system. Now, as I was just mentioning, the beauty of a weave is in continuity in both directions and in being supported and supporting alternately. In timber, if you want to do any construction, the beauty is in ensuring that you get member fiber continuity in both directions and in using the entire cross-section of timber itself. It's not a hollow element like steel. It's not made up of different discrete elements like concrete, but it is a cross-section that you use. So you get this, you get a weave in timber elements. But more importantly, how do you build that? Because ultimately, you can conceive something, you would need to build it. So the idea was you splice these members at one location, and you connect all of these together, the rods, the timber, which is going in two directions, but only splice the top member, but not splice the bottom member, which means that you can build it easily by supporting it on the bottom member, but also once you do this connection, it is similar at all locations. Now, as we just heard, we are in a generation where a lot of the fabrication is driven by digital models. So in a way, the curved glue lamp that would make part of the weaving shell is a story of today's construction. Timber construction today is driven by technological advancement, where CNC-driven fabrication basically allows you to take the digital model and drive the machine that fabricates each piece to its correct geometry. And then you do it by checking. And here, if you are able to then optimize the curvature of these members as they are going through from the support to all the way to the cantilever end, what you can get is you can nest them and mass fabricate them, almost making it both modular and ready for fabrication of all elements at the same time. Now, the realization of from a concept to a reality is in both, in making sure that what you've designed is actually able to make it, fabricate it, but also are you able to build it? And that's the next challenge that we face. Can we do these? Can we actually fabricate each of these elements from a computer-generated model and then bring it together? There's like 1,500 components that can be only 24 different member element types that you then connect and possibly build it upwards and inwards without using any false work or any shoring. You could also prefabricate all of these. And one of the advantages of our site that we have chosen is that you could prefabricate a lot of these things and ship it on a large barge and not be restricted to logistics of ground transportation. And once you've done this, you've got is a true representation of architecture that is the form itself. And this is what shows In a way, this image is a story of the architectural and engineering design integration that creates this basket, this weave of the structure itself. When you look at it closely, you see these elements connect together. And if you look at it, if you had the X-ray eyes, you would see that these are simple connections that repeat itself. Hence, you can mass fabricate this, a modular structure, and bring it to site and bring it together. We also took the approach of mass timber all the way into the inside elements as well, where you could use concrete slabs supported by CLT formwork, supported on conventional post and beam system along with CLT as a lateral system. What you do is, for the building type that we were designing, a stadium, the structure is a large component, usually greater than half of the embodied carbon of the building itself. And by using mass timber, you can actually shave off 25–30% of that embodied carbon. Makes a compelling story, the use of timber.
So what does that look like? So we come back to the context. So now you have this sort of iconic object nestled at the water's edge. You could develop that around it. It's got these incredible kind of raking views. You can, connect the city all the way to the water's edge, which in this area it has not done. One idea also that we had as urbanists, having master plan Cornell Tech, was to modify the tram so that it had a stop on the island, but also a second stop on the East River on the Queens side. So you could be in Midtown Manhattan and take a 2-stop tram to a game. Obviously, that extension of the landscape that is to the south and to the north is finely stitched together. You have a complete edge, and this entire site is then elevated up to elevation 18, which is getting that kind of requisite protection for the neighborhood behind it. It is, a kind of incredible blimp shot. You have to think about the blimp shot when you design a stadium, but this idea of kind of like suspended above the city, the energy of that idea, there is a shell that covers it of ETFE, which is a very thin polymer. One of the key things about timber and its challenges is not only long-term protection, but also protecting it during construction. And it's not just moisture, it's also UV. And so that ETFE would control for both of those, and obviously also protect the spectators when the game is going on. But it has this kind of beautifully pure structural expression from the outside as you approach it. When you arrive, the concourses would be open to those views. You would look around. You would see both of those timber systems, the hybrid system on the right and the shell itself on the left. Somehow, the U.S. is beating Brazil 1-0, although if you look on aggregate, Brazil is still ahead of the U.S. But the stadium is doing something. It's a great home field environment. And I return to that sort of romantic image that we showed earlier of what it is like to be in a stadium. And if that was a cradle of timber instead of a cage of steel, I think that changes hearts and minds.
So I learned a lot tonight because I was delighted to see how many of the architects continued to work on this project after we published or after they had delivered all their final materials. And I should point out that we have links on the online version. So the online version of this article went up this morning. I believe it should be outside the paywall, so you can all see it. And it will be in print next week in a somewhat modified, not all of the pictures that are up on that website will have made it into print, but it still looks pretty good. Looks really good. And in the online version, there are links to the pages that each of the firms created to go into their projects in a little bit more depth. So you can just click on those because we were limited in how many images we could create. And of course, they did all of this far beyond what really we could accommodate. So I learned a lot throughout this whole process. And tonight, I'm curious what you guys learned from doing it. Since this was as much an exploration for you as it was just an assertion of what you already know. Kate, you want to?
Sure. I think it has been a really fascinating exercise from beginning to end. But I think what sticks with me right now is just seeing this group and seeing how there's the sort of common themes. Everyone talks about some of the same things, but then the results are so different. So I think it really does demonstrate, the capability of timber and the creativity that it can manifest, that I think would be really fascinating here.
Yeah, and I should say that these guys did not consult with each other as we were going along at all. They had no idea what the others were all working on. Just anybody else want to talk about what they, Chris? Yeah, go ahead.
Sure, I'll go. I think what maybe resonates the most with us is realizing as we're investigating a similar typology of project in our home state and then facing the same issues here, that like it's all the same conversation about what mass timber can do and should do. Regardless of where you go, let's just keep it to America for a second, and the potential for using the resource that's available to us that's so sustainable in all the ways we've been talking about. But as we dug in and we're trying to understand what this site could be and what it could be for the New York public school system, that it has all the same issues, and the issue really is people, students, it's children, and so those same qualities of what mass timber can do, I think, just resonate across all the projects. So it's sort of, I guess, fortifying in some ways.
I think what for me and Chris and Steve and the team was when we get these little exercises, and these are short bursts. And for us, the pavilions that we've done in the past are really where people really get to test their ideas, whether it's, the digital tool or the technical aspects of the material. In this case, we really wanted to think about like, how can you create a long span and it's doing everything. And, we did call TT, Thornton Tomasetti. It's just like, we didn't, as I said, you can't
introduce you to pre-sum.
Yeah.
Would have been so much.
So the point is that it's not, this whole idea, and, this whole idea, it's coming from one person. This material really has to take a lot of embracing from many different perspectives. When you talk to a master craftsman, a carpenter, they are very set. They're very specific. They have specific tools. And then you got us who are just going to go to an extreme to see how far we can push things. And so it's always important to bring the right people into the process early. And I would say on the Carousel House, that's exactly what happened. You start your first project, it's a public works project. You have a contract, you better not screw up. And so you bring a great carpenter in, you ask questions, if you don't understand it, you keep asking, and then you build models. And that's kind of been the process at Shop all the way through, is that it's the whole execution, the making, that's the exciting part. And when it's done really well, the craft just permeates from that experience. So I think for us, the frustration is we're not building it. Hopefully we get to test this idea out. But anyway, it was also great, hear the evolution of everyone else's projects. And hopefully some of these do get built at some point in time.
Yeah, you hope. I mean, it's almost, I will go in a slightly different direction to you, in the sense that I think getting the call from Justin, whether it's you or someone else, when these opportunities come where someone says no site, no budget, no whatever, but make it real, those are really exciting moments for us as designers, because we're all operating as a practitioners, you're operating in an incredibly constrained reality. And that for good reason, because these buildings have to stand the test of time. They have to be safe. They have to be all these other things. Even the slightest loosening of those constraints, though, is incredibly exciting for us, because it allows you to sort of step out of the mode of practitioner and into the mode of experimenter or innovator or visionary. And usually you want those then to reverberate back into your practice. And so this is a chance for all four of our practices to prototype something that then we can find an application for. And I think some of the most important buildings in the world were designed that way. The anecdote I will tell is that, at SOM's founding, Nat Owings had a plan drawn up for an international style skyscraper with a horizontal podium and a glass tower that sat on top of it. And he tried to sell it to about 15 clients. And then the Lever Corporation bought it. And that's what Lever House is. It was a prototype that found a client visionary enough to build it, and that's where a masterwork comes from. So hopefully 20 years from now, we'll all be touring each other's buildings. I don't know.
So hopefully those clients are out there. Pritam, did you want to? I encourage you to ask each other questions. I wanted to throw this out there to however you want to answer it, whoever wants to answer it. So much of the conversation around mass timber is predicated on the sustainability aspect, and I know that you're all believers in that. And there's certainly research that shows how much better it performs environmentally than carbon and steel. As Colin pointed out, often it's a matter of like trying to compare different building systems for the same project. But let's say, as we learn more about the realities of forestry, about the demands of, about the cost, about the demands of the process of making the adhesives, of all of that sort of cuts into that sustainability as we figure that out. What's the core value for all of you that goes beyond that? Or let's say that sort of got taken out of the equation. What is this material about for you if it's not that? You've talked about some of them. I know you were talking about wellness. Can you expand on that?
Yeah, I mean, I think the thing that's so meaningful about timber is that people are so responsive to it. Just as humans, there's something about it that's so tactile, so friendly. We're comfortable with timber. It changes our perception of architecture. And I think that came across in all of these themes, that you could imagine any of these buildings, like the school with the corridor, that the kids, being comfortable there, and that sort of feeling of walking in the corridor and touching it. And that would never happen with a concrete block, or, even the stadium, the same thing, seeing the layers. And it's just a very organic, very human material. And I just think it's a fascinating moment. I love the way you talked about it, Justin, that we've seen what happens when we started developing steel systems, when we developed concrete systems. I think we're at a moment now where we're thinking about, what if we look again at timber with modern systems, with everything else? How do we fold that together? And it's a very systematic approach and a technical approach on one hand, but on the other hand, it's a very poetic, very human centered approach.
Well, it's strange. You think of majority of timber used as stud frame construction, and it's ugly, and it's basically a secondary system. And, it's all graded based on what you can see. And what I find when you start, you look back at historically, you look back at craft and celebrating material and how it's made and finished and detailed. And what, we always say the most sustainable thing is something that people are going to take care of forever. It will never be taken down or fall apart. And I think that's what's so exciting about mass timber, because it is all in the detail. It's all in the craft. It's all in the engineering, and people can begin to understand it. It's even with building like this, you understand it, in terms of what you think it is, but you really can't see how it's made and what's holding it up, in a sense, other than what or have been educated. In a timber structure, and I grew up in a 1732 farmhouse in Chester County, Pennsylvania, and you could see how the building was changed over the decades and so forth. So that, for us, it's really this kind of informative experience that's very human. And so I think in terms of the way wood is used in mass timber construction, or CLT and so forth, really kind of gets us back to the nature of the material as we've always known it in terms of our ancestors.
I would just parlay on that and say that I think of it as a one-to-one. Like, someone can walk in a building and see a wood column and understand that was a tree in some way, shape, or form. But if you move beyond architects and engineers, like, most people don't know what concrete's made of. No one has any idea how steel is made, but you can understand how wood is made. Like, you understand where it came from, where it once existed. And now it's there in front of you. And I think that to exactly what you're saying, it just feels like a stronger one-to-one human connection.
Yeah, I just add to that is that when you look at the CLT stair there, that is the timber. That is it in its natural form. It's like eating natural food versus highly processed food, right? It's concrete and steel is highly processed. It's not the natural inherent properties. You don't get to touch and feel and see it. It's highly processed. What you get to see in timber is what it looked like, what it is in its natural form.
One of the things that really struck me as I was thinking about this was how much it's simultaneously, you know, as you've all emphasized, simultaneously a really contemporary material because it relies on contemporary technology. You really couldn't have these expressions of mass timber without that, and you wouldn't have been able to realize a lot of these things even 15, 20 years ago in this way. But at the same time, it's immediately in the same way that you can see it and know what it is, it's immediately evocative of thousands of years of tradition that people respond to. And much of that tradition is highly wrought, right? If you think about, you know, Japanese timber framing and you know, hammer beam roofs and you know, all of the stuff that is in our collective cultural memory and that comes from all over the world. It's kind of obvious, right? The way this material interacts with that cultural memory. And that's one of the things that I find exciting about it, is this idea that it's simultaneously it's a new way of using an old material. And so it's however strange you make the architecture, there's something immediately familiar about it. All of these buildings, it's not deceptive in that way, and it's very comfortable for all those reasons. But I wonder, given that, how does that change your thinking in the design process when you're participating in that? It's a very open-ended question, I know, but what is it like to engage with that history and those possibilities? Not handing it for you to go first if you don't want to.
Well, I can start. Maybe we'll go the other direction and end with the Z. But I do think it's not just timber. I want to start with that. We're at this interesting inflection point where a big chunk of the last century was focused on building assembly lines of construction that were quite rigorous and disciplined and didn't offer the designer nearly as much ability to craft and customize that, say, the century before that, you know, in arts and crafts movements or other things like that. And I think that what you showed in those beautiful terracotta images, you think of mass timber, you think of some of the sort of ability to 3D print very specific subjects. You actually, as a designer, are being able to sort of be more deeply reconnected to unique expressions of architecture. And as you do that, I actually think now we have this explosion in the vocabulary of architecture, which is challenging because like these cities have integrity and they're sort of being pulled apart at the seams by a lot of different ways to attach it. What I think timber in particular offers is the ability to feel immediately familiar, even if its expression is new. And I think that is there's very few materials that can reach that level of comfort in people without trying. And this is a totally off aside, but there was an album that Bjork made in the 90s. I love Bjork. And in an interview, she had talked about wanting to use strings because strings have this kind of emotional resonance when they're pulled that resonates in all humans, and you can meet them immediately at something they're familiar with. I think of timber that way for architects. Like if you're wanting to pull the person towards your work, you can work in timber and you know that you're going to get the audience that you want.
It's interesting because there is this tension of it's a very old material, very human material, but we still have mechanical systems. We still have electricity, we still have plumbing, and in a building like this, we know how all of that works. But as soon as we design a timber building, we're thinking about a new kind of system, and I think we're questioning each one of those components, and we're coordinating them, and we're depending on high-tech CNC, production and prefab, and it sort of is a very sort of forward-looking material as well, because we don't need to do that with some of the other materials we use. We know how we do it. We've been doing it, now for 50 or more years in a modern building. But timber causes us now to revisit each decision. What's the floor made of now? Is it concrete topping slab? Is it on wood? How do I put the lighting in? Is it between these cassettes? Where's the mechanical run? So it's a really, really interesting moment. And I hadn't thought so much about it until you mentioned it. But when I think back at the Portland airport, there's a huge prefab story. We think of it as a timber story, but it's also a huge prefab story, which is really fascinating.
I would just say that for me, and I would just say for me and my brother in particular, because we're big aircraft, nautical, car people. You come to the office, there are more car, airplane, boat miles than buildings. And it's interesting, even in terms of sailing, you see, a wood boat. You smile. You look at it. It's been designed to do something very specific, and wood was utilized to get there. And you look at the early aircraft, building something incredibly light, a material that you could control and develop a wing, whether it was wing warping or the more traditional ones, or even the early automobiles and the coach work was wood. So when we started thinking, but architecture comes so much later. There's so many other variables. Chris and I always say, so much easier, to make a plane versus trying to do a modular building in architecture, because you've got the regulatory issues we have in New York, but it has to solve so many things. But wood has the capacity of doing that. It's just a question of getting our code officials and everyone on board with it. And it's really frustrating to see the rest of certain parts of the country, Europe, China, Australia, really pushing the limit. On the Lassian Tower, the fire department was, the department was involved in the process right from the get-go. And that's what we need in terms of, we hear politically deregulation support. Okay, fine. Get the people in the room, work with the designers, get the rate and prove out the systems and so forth. But it's one of the biggest frustrations, because when you look at the early pioneers of aircraft, ships, and auto, they didn't have to deal with that. And they made it, and then it worked, and then people saw it work, and then it kept going. And I think that's the biggest frustration we have in terms of our New York landscape, of trying to get beyond that.
In the middle of working on this project, I happened to read David Grand's The Wager, which is about an 18th century ship voyage. And it goes into the construction of the ship. But one of the most amazing things, thinking about life cycle analysis and recycling materials, is that this ship, which was built in Southampton, or sailed from Southampton, I think, crosses the world, goes around the point of Patagonia, and shipwrecks on an island, winds up on a reef. They swim to shore, all these sailors, and then they rebuild other craft from the wrecked ship. They have the carpenters there, and on the ship, they manage to salvage some tools, and they build another ship. Just the idea that you can do that, that's sort of, inherent in some of these materials. And one of the things I was wondering about, it sometimes feels like when we talk about the constraints on architecture, especially in New York, it's not just the regulatory environment, it's a supply chain also, right? We know the cost of these prefabricated materials, facade panels and joints and so on. We know that they perform, we know their ratings, we know where to get them, we know how long it takes to ship them from China or wherever. Lenders are comfortable with buildings that are built according to procedures we're all familiar with. You can get comps and so on. Developers know what they're getting into. It minimizes the risk. So at the same time as we're talking about a prefabrication story, and this is about an industrial process, can you guys talk a little bit about what's involved in trying to do an end run in a way around that supply chain and all of the known procedural and design considerations that go along with that? When you're building in mass timber, yes, we have some experience. There are manufacturers and so on, but there's a lot more change happening day to day.
Well, you source all the timber from Arkansas. That's one of the things we learned today. But I think more or less it's become evident that timber as a material, you can replenish it more sustainably than any other materials in construction. And that's fundamental. And what we were just speaking about, the technological advancement actually allows you to eliminate waste. And waste in timber has been one of the problems of, you source a tree, you're cutting down a tree, but are you able to use as much as you want to use it? Are you wasting? The technology today allows you to maximize the use. You can nest things, you can get as much timber as possible from every tree. And that itself makes it feel like you want to use that material. One of the things me as a structural engineer I love about timber is that it's one of the materials that all architects want to see in their final product. All of the renderings we saw today didn't have an enclosure or a cladding system to hide the structure. It's a material that everybody wants to see, touch, feel. And I think that's another thing that the timber allows us to do. And you mentioned the Japanese craftsmanship, carpentry, timber joinery. Some of the things, including the connection detail that we were thinking of, originated from that. The splice detail, the idea that all of these can come together. How did the Japanese carpenters do it? And how can we do it today using the technology and prefabrication opportunities to get to that same thing that they were doing individually at a smaller scale? Can we replicate that to a much larger scale and use it, prefabricate it, make it modular, make it more acceptable on all building types? And I think that's what I see us doing more.
While you're on that joinery issue, I have a very specific question from somebody in the audience saying it looks like the splices were made at the joints as opposed to 18 to 36 inches to the left or right. What is the advantage to having the splice at that location? Were there any concerns with instability?
That is a great question. That was actually a specific conclusion that we came to as to why we spliced it at the location we spliced it. These members were primarily members in compression, that is continuous force that you see, and they are not bending about the point that they're supported on. And that's it originated from a reciprocal structure. What you support, something else supports the third thing, and the third thing supports you back. So it was not one thing that was just going and supporting something else that was going over it. The beauty of that whole thing of getting a continuous member at the bottom and having it spliced at the top meant that you could just continuously construct, bring from one side and keep building. It's almost as if, and you turn around and you do the same thing on the other side, because one side is going up always, as the other side is coming down. If you keep the down as continuous, you've been able to splice every single member and do it. And in one of the things that you do, you stay away from the center point of support is because you see that maximum moments. But if you're able to make this into a two-way system where all the forces ultimately come down to the ends as axial members, you've been able to eliminate that stress point. And again, the form finding was also trying to eliminate stresses and make it uniform, because one of the things we want to see is we want to mass manufacture, we want to fabricate it. So you want some amount of uniformity. And if you have members that are horribly stressed versus not so stressed, and you have them all the same size, you've designed for the worst condition. Again, you've wasted the material that you would not.
We're gonna wrap it up in a minute, but I just want to. There's another question from the audience that I also had, which is, can you just can anybody address some of the specific problems of dealing of using mass timber, especially in a northeastern climate, and with whether it's a deterioration of the elements in the weather or discoloration. Obviously, one of the things about the New York code is that you can't use exposed timber on an exterior facade. So, in fact, you've actually all protected those from the weather. But what are some of the specific things that like are tricky about dealing with it, especially in exterior conditions? Colin, you guys built the bridge that's hanging out there in the rain.
Yeah, I'll start quick. But the bridge, if you look at it closely, there's a gap between every member that's quite large, and that's so that the water can drain out of that. It's got a peaked profile at the top of that trusses. It doesn't have a horizontal surface. You have to be able to design, if the wood's exposed, they have to be able to allow it to shed the water. It cannot, and then there's a big difference, again, fiber strength between the face of the wood, which the grain is running on, and the end grain. And if you get water into that end grain, it's immediately going to be problematic for the system. So if it's an exposed system on the outside, it has to be protected from those things. When we've talked to contractors and tried to pitch it at large scale, one of the things the contractors really object to with mass timber at mega scale, and I'd love to hear how it went at the airport, is they have to increasingly either move fast, build it, enclose it, or temporarily protect it while they're constructing it. And there's cost with that. There's logistical complexity to that. They all find that one of the biggest obstacles.
All right, well, let's leave it there. Thank you guys so much for your participation tonight, for all the work you put into this project. I can't tell you how grateful I am that this happened. I want to thank Carol, SOM, for hosting it. My editors, Chris Bonanos and Suk-Jung Hung from Curb, who are here, who really saw this through and made it possible to do it, because it gave these ideas a home. And all of you for coming out tonight, and hopefully one day we'll see these happen. Yeah, it's a race. That's why we have this.